Okay, look closely. I promise you, there is a cuttlefish right here on the screen. Can you see it?
Still nothing.
Right. And that's the core riddle of camouflage, isn't it?
Yeah.
It forces you, the observer, to really question what's real and what's actually visible.
It's fascinating.
Today, we are taking a deep dive into this world of cryptic coloration. And look, this isn't just about basic hiding. We're talking about a whole universe of creative adaptations.
Yeah, used for both defense, hiding from predators, and also for attack strategies. We're focusing on the real masters of invisibility, both the active kind and the passive kind.
And our mission today, really, is to give you the ultimate shortcut. We're pulling out the most surprising, the most effective tactics from the wild.
We'll be covering, well, all sorts: insects, birds, mammals, and of course those incredible shapeshifters, the cephalopods.
The methods are just wild. You've got creatures that are basically transparent like a comb jelly.
Right, or others using this ultra-black finish to vanish in the deep sea. And then there's dazzle camouflage, like high-contrast stripes meant to confuse rather than conceal.
Okay, so let's unpack this. Where should we start? Maybe with the classic strategy, becoming something you're not.
Good idea. The art of stillness and perfect imitation, mimesis.
Mimesis, right.
And for that, you have to start with the giant leaf-tailed gecko from Madagascar. I mean, it's literally in the name.
Its tail looks exactly like a leaf.
Exactly like a dead, decaying leaf. It's broad, it's flat. Perfect.
Which is just brilliant, isn't it? Because what predator cares about an old leaf?
Precisely.
But, okay, even if you look like a leaf, there's still the shadow problem, right?
Yeah.
A perfect blend can still be given away by the shadow it casts. How do they beat that?
Well, they flatten themselves. But there's more. The giant leaf-tailed gecko has this specialized flap, like a fringe, that runs along the underside of its body.
Okay.
So when it presses itself flat against a tree trunk, that flap sort of seals the edge. It completely gets rid of the shadow.
Wow. So it basically makes itself look two-dimensional against the bark.
Exactly. It just blends right in. That structural tweak just to kill a shadow. It's incredible.
And that technique, it's not unique to them, is it? I think I read about a spider.
The wraparound spider, yes, an Australian orb weaver.
Yeah.
During the day, it does something very similar. Flattens itself out, people describe it as a pancake shape, and physically wraps around a branch.
So it's using background matching and shadow elimination, both at once.
Double camouflage.
Yeah.
It really increases its chances of just not being seen. Super efficient.
Okay, let's shift scenes. Under the water, you get creatures there that seem like they were just born to be hard to spot. They have to rely purely on placement, right? Like pygmy seahorses.
Oh, they are absolutely adorable and incredibly stealthy. They're part of the Syngnathidae family, which also includes pipefish and other sea dragons.
Right.
And they just cling to specific types of coral, usually Gorgonian corals, and just hang out, feeding on tiny plankton drifting by.
And finding them, even the known species in the coral triangle, it's supposed to be a huge challenge for divers, right?
Right.
Because they mimic the coral's shapes and colors so perfectly.
Absolutely. Born hard to spot. And then you've got the leafy sea dragon off Australia's coast.
Another amazing one.
It looks exactly like a piece of floating seaweed or kelp, those leafy appendages all over its body. Perfect mimicry of the surrounding aquatic plants.
And it can change color a bit, too, under certain conditions.
Yeah, subtly. Just an extra layer to the disguise.
So what's really striking here is that all these static camouflage examples, the leaf gecko, the seahorse, the sea dragon, they all demand that the animal stays incredibly still, right?
Yeah, movement is the enemy. They rely entirely on that perfect imitation or finding the exact right spot.
But what's the trade-off there? Staying still must save energy, but
it's a high risk if a predator stumbles upon them, or if they need to move to find food or a mate. If they move, the illusion shatters.
which sets us up perfectly for the next level, doesn't it? When animals don't just mimic the environment, they actively become the environment as they move.
Yeah.
Active camouflage.
Or adaptive camouflage, yeah. And this is where things get really spectacular.
And the undisputed master has to be the octopus.
Oh, absolutely. The octopus is just phenomenal. It achieves these rapid shifts using specialized cells just under the skin. They're called chromatophores.
Chromatophores.
Yep.
Right, I've read about those.
Think of them as thousands of tiny sacs filled with pigment black, brown, orange, yellow. Muscles around each sac can stretch it wide open, showing the color, or squeeze it shut, hiding it instantly.
It's like a living, biological, high-definition screen.
Pretty much. And it's not just color, they change texture too.
Wow.
They have these projections in their skin called papillae. They can raise or lower them to make their skin go from perfectly smooth to bumpy or even spiky, matching rocks or coral.
That's incredible. And they need that speed, don't they? Because so many things want to eat them.
Oh, definitely. Moray, eels, seals, whales, sea otters, even birds. Disappearing in a flash is crucial for survival.
And some take it even further, like the mimic octopus. It doesn't just blend in, it pretends to be other animals.
Yeah. Yes, it's the ultimate performance artist. It can change its shape and movement to impersonate dangerous creatures, maybe a venomous lionfish with its stripes, or a poisonous sea snake that scares predators off.
Or to copy something harmless.
Right, like copying the way a flounder looks and moves across the sandy bottom just to cross open ground safely. It's astounding mimicry.
So the mimic octopus is the actor, but its cousin, the cuttlefish, that one's all about the tech specs, right? The resolution.
Exactly. If the octopus is the performer, the cuttlefish is the ultra-high-res screen. Get this. They can have up to 200 chromatophores per square millimeter.
200 per square millimeter. That's insane.
It's a resolution higher than any TV screen we have. It allows for incredibly fine-tuned patterns and textures. They can seemingly vanish in a fraction of a second or instantly adopt complex patterns like zebra stripes. It's like real-time, high-def texture mapping on living skin.
Mind-blowing. Okay, before we move on from color change, we have to clear up a common misconception. The chameleon.
Yes. Everyone thinks chameleons change color primarily to hide, like the octopus or cuttlefish.
But that's not quite right, is it?
Not mainly, no. While they do use duller greens and browns for camouflage when resting or avoiding trouble, those really dramatic, bright color flashes, that's mostly about communication.
Communication. Like what?
Things like courtship displays, warning off rivals, territorial disputes, or just showing excitement or stress. For males, the brighter the colors and the faster the change, the more attractive they might seem to females. It signals fitness, energy.
So it's more about showing off than hiding in those cases?
Largely, yes. The camouflage part is more subtle. The communication part is flashy.
Okay, so if we connect this back, the difference between the octopus's fast, dynamic changes and the gecko's static pose really highlights a big trade-off in survival, doesn't it?
Absolutely. It's about energy. The octopus and cuttlefish invest a huge amount of metabolic energy into maintaining and operating that incredible skin system. It's costly.
Whereas the gecko, being still, saves energy.
But runs the risk of being found or being stuck in the wrong place. Big difference in strategy, driven by different pressures and different physiologies.
Right. Okay, let's shift gears a bit. There are some, well, quirkier approaches to staying hidden too, right? Like basically hiding under trash.
Yes. Self-decoration. It's surprisingly effective.
The decorator crab is the classic example, isn't it?
Perfect example. Its shell has these specialized hooked hairs, almost like Velcro, and it actively picks up bits from its environment, sponges, anemones, seaweed, bits of coral.
And just sticks them all over itself.
Exactly. It creates this living, mobile heap of debris. Sometimes it even picks up smelly or toxic things to actively repel predators. It's a walking disguise kit.
That's brilliant. And other creatures do this too.
Oh, yes. Lacine larvae, for instance. They pile up the empty skins of aphids they'd eaten, bits of plants, even their own droppings, and carry it around on their backs.
A literal trash shield.
Pretty much. And even octopuses sometimes get in on the act. They've been seen carrying around 2 halves of a coconut shell, kind of like portable armor, while moving across the ocean floor.
Okay, gotta love the ingenuity. What about dealing with massive environmental changes, like seasons changing?
Yeah.
Snow.
Seasonal camouflage, yes. A whole different challenge. Think Arctic hares, Arctic foxes, caribou.
They change their coats, right? Brown in summer, white in winter.
Exactly. They molt and grow a coat that matches the prevailing landscape, brown or gray for the summer tundra, pure white for the snow.
But that timing has to be precise, doesn't it? What if the snow comes late or melts early?
That's the huge risk. It's called phenological mismatch. If the animal changes color too early before the snow arrives, or keeps its white coat after the snow melts,
they stick out like a sore thumb.
Terribly vulnerable to predators. And this is a growing concern with climate change, unfortunately. Shifting seasons can increase that period of mismatch, making it really dangerous for these animals.
That's a really important point.
Yeah.
Okay, we should also touch on something different. Not hiding completely, but maybe confusing the predator. Dazzle camouflage.
Right. This isn't about blending in, it's about breaking up the body outline or confusing the predator's visual system. Think zebra stripes.
The classic example, it doesn't actually hide the zebra.
No, not against a plain background. But in a herd, the mass of moving stripes makes it incredibly difficult for a predator, like a lion, to single out one individual. It might also confuse their judgment of the zebra's speed and direction during a chase.
It's visual chaos. Giraffes use this too, right? Their patches.
Yes, that complex, high-contrast pattern breaks up the giraffe's outline, making it harder to see the whole animal shape, especially from a distance or in dappled light.
Fascinating. And then there's the flounder. We mentioned it briefly with the mimic octopus, but the flounder itself has one of the most incredible developmental journeys just for camouflage.
Oh, it's truly bizarre and amazing. Flounders aren't born flat.
No, they start out swimming upright like normal fish, right?
Yeah.
One eye on each side.
Exactly, symmetrical little fish larvae. But they're destined for a life lying flat on the seabed. So within days or weeks, something incredible happens. They start to tilt, and one eye, usually the left one, but it depends on the species, begins to migrate.
It actually moves across its head.
It literally moves over the top of the head.
Yeah.
The skull bones actually twist and remodel to allow this migration. Eventually, both eyes end up on the same side of the head, the side that will face upwards.
That is just, wow, nature committing fully to the bit.
Absolutely. The bottom side, the one facing the sand, loses its pigment and becomes pale. The top side develops that amazing camouflaged pattern to match the sand, gravel, or mud perfectly.
So they end up using perfect background matching, and they're flat, so they eliminate the shadow problem too.
Yeah.
Just like the gecko and the spider we talked about earlier.
Exactly. A lifetime benefiting from that radical transformation.
Okay, one last area maybe. We've also talked about prey hiding from predators. But predators need camouflage too, right?
Definitely. Both for ambushing their own prey and sometimes for hiding from even bigger predators. Think of owls.
Like the eastern screech owl.
Perfect example. Its plumage, the pattern of browns and grays, matches tree bark incredibly well. If it senses danger, it will sit bolt upright, pull its feathers in tight, and close its eyes. Those big yellow eyes would give it away.
And it just vanishes against the tree trunk.
It really does. And smaller owls, like the little owl, use their mottled brown and white feathers to hide from their predators, bigger owls like snowy owls or great horned owls or eagles.
So even predators need to hide. And sadly, for the little owl, camouflage isn't enough sometimes. Habitat loss is a big issue.
Yeah, unfortunately. Changes in farming practices, loss of old trees and hedgerows, it impacts their prey, like insects and small mammals, and their nesting sites. So their populations have declined quite a bit in some areas. It's a reminder that even masters of disguise are vulnerable to wider environmental changes.
Right. A crucial point. Well, that brings us pretty much to the end of our dive today. We've covered a huge range, haven't we? From geckos looking like leaves and crabs carrying junk.
To octopuses and cuttlefish with skin that's basically like living technology, surpassing anything we can build.
And the reasons are just as varied. Defense, attack, even courtship, like with the chameleon.
It really shows nature pushing the boundaries of perception, doesn't it? These examples force us to appreciate just how sophisticated biological solutions can be. The engineering involved is just stunning.
It really is. So maybe here's a final thought for you, our listener. If all these incredible creatures rely on invisibility, on manipulating perception just to survive,
And if we could be so wrong about something like why a chameleon changes color,
then how many other critical biological things are happening all around us? Things that are maybe just as real, but that we haven't evolved the senses or the tools to perceive yet.
what else is real without being visible to us?
Exactly. Makes you want to look twice at the world around you, doesn't it? Maybe that pigeon isn't just a pigeon.
Maybe not.